Where will the universe ultimately expand to? If expansion never stops, what will its final fate be? Under the scale of physical laws, the answer has long been written. Given enough time, even chaos can be precisely calculated. The ancients used seas dry up and rocks crumble to describe eternity. But in the eyes of the universe, human civilization is almost non-existent. Even Earth's 4 billion years are but a fleeting moment. This is neither mysticism nor prophecy. It is physics. Before the deductions of the second law of thermodynamics, all things are equal. Next, you will cross a timescale beyond intuition and head straight to the edge of physics. Now, you move the hands of time, directly entering the ultimate truth, eternity, stripped layer by reason. When it returns again in the year 2366, this comet's every passage through the solar system is essentially a precise demonstration of gravitational slingshot effects and orbital mechanics. It does not care about the stage of human civilization below. It only follows Kepler's laws with absolute precision. Are you used to thinking of the sun as the eternal ruler of the sky? That common belief will soon be corrected. In 10,000 years, the red supergiant Betelgeuse will reach the end of its evolution. It will explode as a supernova, so bright it could be seen even in daylight. But this is not mere destruction. It is the gamma-ray outburst released when the star's core collapses after exhausting its nuclear fuel. Even stars, massive as they are, must obey the law of energy conservation. Once their fuel is spent, the end is inevitable. Do you think a day will always be 24 hours? No. Time is being stolen by physical processes. Earth's rotation is slowing because the moon's gravity creates tidal bulges in the oceans. This tidal friction continuously drains Earth's angular momentum. Every century, a day grows longer by about 0.02 seconds. In 50,000 years, we will need to add an extra second to each day to compensate for the accumulated loss. Time itself is not constant. It stretches as energy dissipates within celestial systems. At this point, star maps that took centuries to create will become useless over 100,000 years. Constellations are merely visual alignments of stars at different distances. Since each star has its own motion, all constellations will eventually dissolve and reform. The night sky is not a static painting, it is a chaotic fluid in motion. At 200,000 years, remember Voyager 2 carrying humanity's greetings? It will pass near Sirius, but by then it will be a silent piece of metal, its power long exhausted. It will drift through space obeying Newton's law of inertia. Our signals to the universe will be drowned out by background radiation, becoming part of entropy. By this time, statistically, Earth will likely have suffered an asteroid impact. This is not misfortune, it is the inevitability of probability over long timescales. Rare high-energy events become nearly certain given enough time. In 1 million years, weathering will demonstrate its immense power. Even though wind and rain are weak, given enough time, they will erode the pyramids of Giza into unrecognizable dust. Even the Apollo astronauts' footprints on the moon will be erased by micrometeorites and solar wind. Matter's information is not lost, it simply becomes disordered. This is entropy made visible. Around this time, another unstable red supergiant will go supernova, lighting Earth's night sky like day. The solar system is not perfectly stable. In 1.45 million years, the star Gliese 710 will pass through the Oort cloud, disturbing countless comets and sending a prolonged comet storm inward. This is a manifestation of chaos in gravitational systems. In 240 million years, continental drift will reunite Earth's continents into a new supercontinent. Geopolitics will be meaningless. Continents are merely floating plates on molten rock. This marks one galactic year, a full orbit of the solar system around the Milky Way. In 300 million years, Saturn's rings will disappear as particles spiral into the planet. Large cosmic structures are often temporary fluid-like phenomena. In 600 million years, total solar eclipses will become impossible as the moon drifts farther away. Meanwhile, the sun grows brighter, disrupting Earth's carbon cycle. Plants will cease photosynthesis and the biosphere will collapse. In 1 billion years, Earth's oceans will evaporate, triggering a runaway greenhouse effect. Earth will become a high-pressure steam world. In 1.3 billion years, Earth's core will solidify, its magnetic field will vanish, and solar wind will strip away the atmosphere. Earth becomes a dead, radiation-blasted rock. In 4 billion years, the Milky Way and Andromeda galaxies will collide, merging into a chaotic elliptical galaxy. In 5 billion years, the Sun will become a red giant, engulfing Mercury, Venus, and possibly Earth. Eventually, it will shed its outer layers, leaving behind a white dwarf, a dense stellar remnant. In 100 billion years, due to cosmic expansion, all galaxies beyond our local group will disappear from view. Future civilizations may never know the Big Bang. In 1 trillion years, star formation ceases. Only black holes, neutron stars, and white dwarfs remain. After about 10 to the 34 years, protons may decay, and all matter will disintegrate into radiation. Eventually, even black holes are not eternal. Through Hawking radiation, they will eventually evaporate after about 10 to the 100 years. These final flashes will be the universe's last fireworks. Eventually, the universe reaches heat death, a state of maximum entropy with no energy flow and no events. But is that truly the end? Quantum mechanics suggests more possibilities. Matter might transform into iron through quantum tunneling. Everything could collapse into black holes again, or the vacuum itself could decay. A false vacuum collapse could rewrite the laws of physics at light speed, like a cosmic system reset. Back to 2026. Sitting in front of your screen, watching the busy world outside, does life still feel ordinary? Every moment you experience is an extraordinarily rare low-entropy state in the universe's long march toward heat death. We are made of stardust, a brief and brilliant dream before eternal darkness.